So we just place it over here. So after I have identified that lymph gland, I take it out of the patient, I biopsy that lymph gland, and then divide it into two and bivalve it. And then we have designed and developed this optical scanner that actually scans the whole surface of the lymph gland, and the signal we get from cancer is different from the signal we get from non-cancer. Comes down. Comes down. Blue is non-cancer, red is cancer, and then move that way and comes up. So this whole square. If that lymph gland is infected with cancer, it means that I have to do more operation under the armpit to ensure I have not left any cancer behind. If I get that information in the operating room, then I can design my surgery, and those patients who have got a problem in their lymph glands, I can make a more extensive operation and save those patients who do not require it.
So they got it down to
It has a significant advantage for patients. There's quite a lot of money.
We couple the two syringes together, and then we add the liquid into the powder. Okay, so the next stage then is to add the needle, which you're going to inject into the body with. And at that stage, we're ready to inject into a cavity. Here we have something that looks like bone, and we can inject it in. That the material will harden spontaneously at body temperature, and over a period of about 15 minutes it will convert from this toothpaste foam-like material into a very hard material which is as hard as human bone. Now at that stage new bone tissue and new stem cells will migrate into that site, and the polymer is biodegradable, so over a 6-month period the polymer will be removed from the body and the site will be completely regenerated with healthy functional bone tissue. With our material, you don't need to do an autografting, so you don't have to damage one part of the patient to move bone to the site that needs damaged. You also don't have to worry about how you're going to get the material in. Ours is injectable, it flows into the patient and forms the right size structure. And then our material isn't rejected by the body, it degrades by a natural mechanism, and as it degrades you get healthy new bone tissue rapidly growing into the site.
And Dr. David Chambers from St Thomas's Hospital, London, for their innovation, a shoulder lifter for cardiac surgery. First winner, in fact, is Pace Max, a method of synchronising pacemakers, and the winner of the Best Technology Award.
For a standard drug, it's about £1 billion, and it takes about 5 to 10 years. And that's always been one of the main problems is that things fail in clinical trials. With our technology, what you're actually doing is that you're defining your patient population in the preclinical stage, so that when you go into your clinical trials, you'll actually be getting a much higher success rate.